Good afternoon, you're still awake. That's good going for an afternoon session. I am biased. We make linseed paint. And my background is in historic building surveying in the Netherlands. I moved to the UK in 2006, first started Histoglass, sold my shares last year in that because my big passion, the paint industry, linseed paint was really starting taking off, and it just needed all my attention. So to give you, I've kind of used one of my other presentations to make it easy today. I'll just run you through the production, short history, actually, and then why it works so well and why we should be using it again. So it all starts with pressed flaxseed. Most of you will know this. Some of you might sprinkle on yogurt in the morning for breakfast. It's very high in omega-3, 6, and 9. We need to have, it needs to be cold pressed. The reason for that is that you want the purest form of the oil that you can start with. A good product starts with good basic ingredients. And then you get something like this. So it's a bit of that honey color. And I'll pass this around. You can sniff it. Now, raw linseed oil has a really low surface tension. So low, it's not actually really suitable for making paint, of turning into paint, because the powder pigments won't really grind properly into the oil, because we use triple roller mills, and you'll see that in a bit, that it doesn't grab. So what we need to do is actually boil the oil, so you end up with boiled linseed oil. Now, another big advantage of that is that the surface tension of the boiled linseed oil is slightly higher than raw linseed oil, but also the polymerization has already kick-started, because you change the molecular chain of the oil. Now, and again, it changes color slightly, a bit darker, and it does smell slightly differently as well. And then we add pigments. And I deliberately use the word pigments and not colorants, because certainly the conventional paint industry, it's all about colorants. It's giving you a choice of 50,000 colors, a couple of drops of a colorant in a base. Nice quick job, off you go. This works in a completely different way. If you make linseed paint properly, you need to use the raw earth pigments wherever possible. Obviously, not all of these are raw earth. We've got some Prussian blue. We've got the metal-based pigments, zinc and titanium, but certainly the umbers, iron oxides, that oak is an umber, there's a carbon black in there. Now, they all have specific properties. This is where it gets really interesting. So we need to make sure that we combine the particular pigments to give the optimal functionality of the paint. Now, the way we mix these, the pigments and the oil, is actually, as I mentioned, through triple roller mill. Before we run it through this mill, we first need to mix it in a big bucket. So literally just big bucket of a boiled linseed oil, we pour the powder in, big mixer, that's it. Now, to the naked eye, that looks like that's mixed, that's great. But what you need to achieve is that essentially, the way we make the paint is the way an artist paint is made. The way, the old masters had like a whole team of like 10, 15 people just mixing, grinding pigments through a muller and slab. That's not really very effective, but we do use the same principle. So, because what you want is each individual grain of the pigment to be completely enveloped in the boiled linseed oil. That gives you the durability. Now, this gives you a brief overview. So once we've actually mixed it, you have this paste which goes into one side of the hopper, passes through the triple roller mill, and then again, comes out in a slightly smoother paste. Now, depending on the pigment grain size, that needs to happen between 2 and 5 times. So certain pigments are much harder to grind, others are really easy to grind. There is the number of times that I get the question whether, questions about color in an historic setting, and whether a particular color is accurate or not. In my opinion, it's very straightforward. If you use the correct historic ingredients and production methods, your color chart automatically is historically accurate. So yeah, we don't use colorants to have, we have literally 2 reds on the color card. And the reason for that is both iron oxide based, one more browny, one more red, but actually historically, when you hold them next to the existing paint on site, that's exactly the color that was there. Now, I already mentioned the functionality of different pigments. Now, I hear a lot of people refer to lead paint. There's no such thing as lead paint. That was linseed paint, but with lead white added to it, or red lead. Now, the combination of lead oxide and linseed oil is really effective, works phenomenally well. It's also highly, highly toxic. So no reason at all to use it if you understand the pigments that you're working with and you combine it in the right combination of zinc white and titanium. You will get to around 80–85% of the efficacy of a lead paint. So you'll never get to the functionality of a lead paint, but I think at 80–85%, without toxicity and the risks coming with it, I think that's the comparison we should be making. Now, another really important thing to point out is zinc white. You can see it here. This actually is on the front door of a place where I used to live. Just painted in regular plastic paint, and it's gone all mildewy. Now, the addition of zinc white helps combat mold growth. So all colors should contain zinc white to combat that. Because one of the big things I come across as well is that people say, oh, linseed paint goes moldy, especially the white colors. Yes, if you just use titanium on its own, you do run that risk. Zinc white on its own dispersed in linseed oil doesn't cover very well, and it goes very brittle over time. So it's certainly not, it's almost like a pigment that you want to use purely for functionality rather than create the color. So why we should be using it now is, and I'm not standing actually here just proclaiming that I've invented the new paint, the be-all, end-all. This is paint that was around for centuries, 500–600 years, if not more. There are traces of actually going further back. The reason why it works so well and why it's so different is because it doesn't actually trap moisture. And the big discussion that we've heard, certainly for the first presentations as well, everybody talks about rot. Now, I can tell you now that pre-Second World War, more or less, the concept of rotting wood was very rare, almost non-existent. These historic buildings that stood for 500–600 years didn't have any problems with timber rotting. And the reason why it all changed is because we started to wrap everything in plastic. Water will always get in. We all know that. Water will always find a way in. You can't keep it out. So the whole mantra of just putting more coats of paint on to keep water out, it just doesn't work at all. So the whole idea is let that thinking go. And work with the concept that, okay, what if water does get in? What happens? Sorry, very long introduction to the next point. I briefly mentioned the low surface tension already. That is really important for penetration into the substrate. Now, here's a good example of what a modern acrylic paint does. As I said, film forming. you can see it here, it just peels off. And we've all probably worked with paint in a paint tray, where, oh, it was so nice and easy to clean up the paint tray because you could just pull out the whole sheet of paint afterwards. That's what you put on your house, right? Now, if you're lucky, it fails and actually doesn't do too much damage. In most cases, and actually this slide is slightly light here, at contrast not big enough, but this is a nail. So what happened, water seeped in and around this nail head over time, and this wood had been painted with a really high, strong alkyd paint. So what happened, this moisture couldn't go anywhere, it just sits there behind the paint. Over time, this wood behind it just started to rot because it's been wet for years. Now, I just used my car key to just test this area, and I just punched a hole through. And I see this so often, unfortunately. So, going back to the point of the surface tension, why this is so important, you can see this here on a very simplified slide. So assuming that you can't keep water out, it's not about direct penetration, it's about what happens when the water gets in behind the paint. So the way I always compare linseed, well, the easiest anecdotal story is to kind of compare linseed paint to Gore-Tex. You go running in the rain, wear Gore-Tex jacket, the raindrops are so big, they're the size that actually don't penetrate the fabric. However, any kind of sweat that you develop underneath is in almost like a gaseous state. The raindrops the droplet size is so small, it can wick out through the surface. So that keeps your body dry, even when you go running in the rain. It is really that simple, and that is how linseed paint works. Now, the big comparison is, if you compare that to an acrylic, alkyd, whatever modern finish it is, that works like going running in getting dressed in a bin bag. We all know how wet you're going to get from that because the sweat can't go anywhere. Big question, if it works that good, if it works that well, and it's so amazing, that must be really expensive. The price per tin is high. This comes down to the ingredients that we've used, as I've shown you, but also the production method. This isn't a quick couple of drops of colorants in a base, but also the solid content of the paint is between about 68 and 72%. So it covers about 2 to 2.5 times as much. Stephen, would you mind passing that around? Just feel the weight. Yeah, exactly. Feel the weight of that. So even though maybe the initial cost outlay is higher, per finished square foot, you shouldn't really be spending any more money than a perceived high-end other brand. That is, however, as long as you apply it in nice thin coats. That's where a lot of the tricky bits come from. Anyway, we'll get to that in a bit. First, I'll talk you through a typical project that we get involved with, or that I used to get involved with. So assume you have a painted surface. So first find out whether this has an historic paint or a modern paint. Now in this case, the customer was adamant that it was an historic paint finish. So I just gave it a bit of a wipe with some methylated spirit, some denatured alcohol. And you can see the cotton tip out there just coloring. So it was just plastic. It's just petrochemical. So that was debunked really quickly. Now, and a good point that previous speaker also mentioned is assume that you're working or you're going to be in touch with lead. So take all the right precautions for this as well. This is there are some very simple, easy, cheap testing kits on, even on Amazon, wherever you want to get it from. You just wet the cotton tip. If it colors like it does here, the purpley violet color, then it contains lead. Now, There are various methods of removing existing paint. I am a big fan of keeping the historic paints, leaving them untouched, if we can. Only remove the modern petrochemical paints, essentially everything that's been painted on the last, say, 30, 40 years. There are various ways of doing this. I've seen people use steamers really successfully, especially on a project in the US, Mount Vernon, which was it belongs to used to belong to George Washington, where they're stripping the whole place. It's a complete timber-clad project, and they're using essentially just a whole bunch of wallpaper strippers, and it just softens the modern petrochemical paints, and you just scrape them off. Not necessarily a DIY job. You need a lot of cheap labor for it to do that. But I'm quite a fan of the infrared heaters, because again they only operate on the basis that you activate the water molecules of the modern petrochemical paints. They just bubble up and you scrape it off. Whatever doesn't come off with that, leave it, because that's an historic paint. And any historic paint is absolutely fine to just paint over with linseed paint. Now, there may be a short clip here. Oh, yeah. So you can actually see how it doesn't actually get very hot either. It's only between 110 and 160 degrees Celsius. It just bubble up and you can just scrape it off. What's interesting as well, you see where there's ever been refurbished underneath, there was nothing historic on there. So somebody already stripped all the previous stuff off and just put some couple of coats of modern paint over it. Now, very briefly on repairs, and previous speakers have done a much better, Toby in particular, much better job on the repair work than I can do. But I always categorize them into three different groups, if you like. So one is either a structural or a very large repair. For that, always scarf in a new piece of timber, or Dutchman repair, whatever you want to call it. Now, a medium-sized repair, I'm still a big fan of using oakum, and certainly with your shipbuilding background, you will know it. It's interesting how certain trades know certain products really well, and if you talk to a shipbuilder, oakum is something they use every day. You talk about the conservation preservation market, nobody doesn't even know what you're talking about. This is oakum. So it's just decommissioned rope drenched in tar oil. I'll pass this around again as well. So what you do with that, I don't know if I have a slide. Oh, yeah, there we go. You just pack your, obviously, it goes without saying almost, but rake out all the rotting wood, all the dead wood, the stuff you need to get rid of, and then pack the hole really tightly with oakum. Once you've done that, use linseed putty. It really is that simple. And if the linseed putty is good enough to glaze a window, is good enough to do repairs. One of the big advantages as well, if you then overpaint with linseed paint, paint it as soon as it's got a skin over. Don't wait any longer than that. You want the linseed paint to bind with the putty for it and then kind of cure together, all as one homogeneous product. In that case, you also don't get this whole issue of putty drying out over time and starting to crack, because it's part of the same family. Where the issue starts is that with modern petrochemical paints, you need the putty to dry first completely for them to overpaint with something that has absolutely no chemical connectivity to it. Knots or any other repairs that you might want to carry out. So I definitely do spot priming. I've seen even 200-year-old doors that were stripped, still bleeding resins. So I'm a fan of just making sure you just treat it with a spot primer. We use shellac. You can, in very certain extreme cases, use an aluminium primer, but shellac usually does the job in 2 coats. And then one of the things that hardly anybody talks about, which is one of the most important things, is your tool selection. Brushes are completely underrated. Now, I kind of split them into two categories. You see the two on the left here. The two on the left really are just application brushes. So these are made from hog's hair. Using linseed paint, always use natural bristle. No synthetic, no hybrid, none of this. Use synthetic bristle. And this comes back down to the, so use natural bristle. This all comes down to surface tension again. On a synthetic bristle, you won't, the individual strands of hair are just too smooth to work nicely with linseed oil. It's a horrible job to paint linseed paint with a synthetic bristle brush. So these are application brushes. Once you've painted, leave the paint for about 20 minutes. Don't touch it, just let it nicely flow out. And then with a laying off brush, a finishing brush, just very gently go over the surface. This flattens the peaks of the application. If you do this properly, then you won't have any kind of brush marks either, or very minimal. And you'll feel how soft the bristle is in this. I do need to hurry up here, I think. Second really important point, thin coats. Anybody who says that linseed paint is very slow to dry, and yes, it doesn't contain VOCs or solvents, so it does dry more slowly than a petrochemical paint, but really, if a coat takes more than 3 days to dry, it's on too thick. It's as simple as that. So you need really thin coats. I'd rather see 4 really thin coats than 2 really thickish coats, because you've managed to kind of make it cover in one go. Maintenance. Linseed paint doesn't flake, doesn't peel. What happens is that over time is that UV light starts to break down the oil on the surface. All you need to do is give it a wipe with some boiled linseed oil. If you do this, and this is the mantra, I think, of this kind of, or what I've heard today anyway, is maintenance. If you can somehow manage to incorporate this in your, say, end of summer, you're putting your garden furniture away, give the windows a wipe with some boiled linseed oil. If you keep doing that, and you keep nourishing the surface, that's all you will ever have to do. You won't ever have to paint, you don't need to scrape anything, you don't need to, so if we can do this, stay on top of it, this becomes not only very cheap, but also exceptionally environmentally friendly. We've already talked about timber quite a lot. I'm with quite a few people here that I have very little time for Acquia or any other kind of man-made versions, and I think they're completely unnecessary. But good Douglas fir, I've yet to see an historic building in Europe which hasn't been built using oak and Doug fir. That shows a lot of problems. Paint in season, if you can, if you're working on site. None of this trying to paint an exterior project in December, which we see a lot of. Now, a few projects I'll go through. Actually, this was I'm going to skip forward to, oh, no, I do want to show you this one. Because you can see the different, this has been applied really well. So this is one coat. You want linseed paint to look patchy after one coat, even after 2 coats. You can see here where the oil absorbs at different rates into the wood. That's exactly what you want to see. If you don't see that, if it looks like this after the first coat or the second coat, it's on again way too thick. This only really starts to develop after you put the 3rd coat on. Oh, yeah, right, talking about applying too thick. Here's a good example. This kind of creasing and crinkling, completely unnecessary. It's just when people slap it on. So this isn't rocket science. It's all very straightforward. There are a few rules that you just need to follow when using linseed paint. And you can see here on the right, again, if you put it on too thick, what happens is, and especially absorbing timber, the oil gets soaked into the wood at completely different rates, and you can get these kind of needle holes. Just where the oil has been sucked in really quickly, and then you get like a film over the top. So this would take years to cure if you leave it like that. I think I'm about on time. Sorry, rushed the last bit. Thank you.